So it's a pleasure for me to welcome the next speaker and the last speaker of this morning's session, Dr. Anaïs Rodrigues. She is from the OBIAChem lab here at the University of Liège, and she will be discussing about the quality aspect of multidimensional separation, especially in the context of non-targeted screening.
Thank you for the introduction, PH, and I would like to thank the four of you for the organizing of this amazing workshop and for having me today. So yes, I will talk about what we try to implement in our lab as QAQC, and for that we use it's okay. Sorry, okay, so it's too close now. And for that we use now the centromics as QC for untargeting metabolomics using GC GC. So you all know that untargeted metabolomics present a unique analytical challenge, which is navigating the immense complexity of chemical data. Here we want to introduce the centromics as quality control standard, representing for us a significant advancement in addressing this challenging. So in this presentation, we will explore how the centromics establishes new possibilities in QC for untargeted metabolomics. But first, I may start with an introduction in QAQC, so sorry about that, but it's kind of needed there. So quality assurance and quality control, according to the ISO 900 on quality management. So quality assurance is part of quality management focused on providing confidence that quality requirements will be fulfilled, and QC is part of quality management focused on fulfilling quality requirements. Those two terms are well known in the industry and for targeted analysis, but here we'll see about that in untargeted analysis and especially in metabolomics. So a lot of people in the field have already played a significant role in developing various QAQC systems. The Metabolomic Quality Assurance and Quality Control Consortium or the Metabolomics Standard Initiative, to cite only those. But despite this effort, we're still lacking standardization and documentation for addressing these gaps in advancing of untargeted metabolomic research. In our lab, we first wanted to implement a new QAQC system. So for that, we first designed our own in-house QC standard. So we called it the QC39. Why? Because it's composed of all the compounds of the grub test mix, which is well known for 1DGC already. But also we added to that some compounds, all the compounds actually, of the cannabis terpene mix B, and then other individual standard, so which lead us to a total of 39 molecules. So it's why QC39. So the idea was to monitor our instrument. So first we implemented our QAQC system on our BT40 GC GC-TOFMS of LICO, which is an instrument equipped with a normal set configuration. And we work for that in liquid mode with very standard mass parameters and with this temperature program there. So for all the analysis we did, our QC39 was with those parameters. So following these methods, this is the chromatogram we obtained. So it's quite good chromatogram for us for QC injection because the space is pretty well occupied, and what we really like about it is that, which is what I call myself the W, some of our team call it the crown. So what is very interesting is here this is a very specific pattern, and with a single look at your chromatogram when you inject your QC, you can see that it seems to be all right already. Here in this pattern, you have like 8 compounds, so you have like some methyl esters coming from the group test mix, but also some alcine that we added to the mixture, and some terpenes coming from the cannabis terpene group mix B. So it's kind of a good overview of our QC. Of course, just looking at the chromatogram is not enough, I agree. So it's why for the follow-up of this instrument, we've been building a follow-up QC chart within a year, and for that we use the score of all the areas for all the compounds of our QC39. So the QC chart we obtained since April, yeah, it was mid-April when I started that, is there. So each point represents the sum of all areas for a specific injection. Then we have the limit in green of 1 standard deviation, in yellow of 2 standard deviation for this sum, and then of 3 standard deviation. So the idea is to follow our instrument by injecting this QC and to see if everything seems all right. So since mid-April and until end of the year, so December, we obtain for all the injection a standard deviation average of 36, which is okay, we'll say. I will just point out these 3 last points that we obtained just before Christmas, because actually it was after column change, because I wanted to see if by changing columns, so we kept, of course, the same stationary phase, same geometry and so on, but still we changed column. I wanted to see if it was still possible to follow the instrument using the same QC chart. And by doing so, actually the standard deviation average didn't change at all, but still we wanted to see. But for the rest of the presentation, I didn't focus on this point, and I just focused on the QC chart we built on the same column, yeah. Here, the first, so the QC chart on the top was the one I presented before. It was obtained with no internal standard correction at all. It was very raw data, just integration of peaks and building of the QC charts. We wanted to see if something's changed, if we use one of the compound of the QC39 as internal standard. So here we chose the ketone here because it was actually the more stable in the mix, and it was kind of in the middle of the chromatogram, so just to see. And as you can see, by doing so, we moved with 3 points that were like a bit below, and it was fitting within the curve. And also we decreased the standard deviation to 15. So that may indicate that sometimes it's useful to look with internet standard correction if those kind of points that are a bit weird are okay or not. But at the end, you have the same tendency. You can see here that we have like a decrease of the response. So, and as I said, at the end of this period, we decided to change column because we observed this decrease, but also on the chromatogram we saw that the peaks change, the shapes and so on, so it was time for column change. So it's another way. So of course, you still have to look at your chromatograms and to the retention indexes and stuff like that, but having a QC chart like that for global follow-up is also helpful to help you monitor your instrument over time. So first, we use our in-house QC39, but with the Consortium project, we wanted to go further. So just a few introduction on this project. So the Consortium project is an internal laboratory worldwide project led by Professor John Dimanja of the FDA and in collaboration with the NIST, with a lot of collaborators here also in the room, I believe. And so this project aims to develop a mixture of about 100 compounds that aim to be used to characterize system and column sets. So this mixture is composed of the alkanes, so from C6 to C20. So this is helpful also for retention indexes calculation, but also some aromatic hydrocarbons, homologous compounds, of course, some Grogmis and microReynolds compounds and other compounds. Us, we wanted to use this centromes as QC to see if it can be useful for QA/QC implementation from Metabolomics. We did exactly the same. We use the same instrument, same column, same liquid injection and so on. The only thing we change is the temperature program, because with such an amount of compounds, we wanted to have a good separation. So we just increase a bit the run to have better separation, but globally it's the same. This is the chromatogram we obtain on a normal set combination for the Consortium. What is very interesting there is thanks to all the homologous series, all the chromatogram itself is a specific pattern of the Consortium. So you have on the bottom the alkanes, but then some alkenes, the secondary and primary alcohol, esters, ketones, and alkyl benzenes. And on top of that, we have like some lactones and also some phthalates. So we really like it because this shape is very specific, and it's the shape with the same condition of course, of chromatogram separation. You will observe on all the same normal sets. As another example, this is what we obtain also on a reverse column set. So we reverse the elation order with second dimension, of course, but we still have a very specific shape. So even if you're not working in your routine instrument on a normal column set, it's something that can be used. Okay, so shapes of chromatogram are nice and so on, but here again, we built like the follow-up QC chart for our instrument, and then before using only the 39 compounds of our QC, we use all the homologous compounds that are in the century mix. So we started that a bit later, so July, but this is the QC chart we obtained for, with the injection. So the average standard deviation following all the homologous compounds of the century mix is 45%. Again, this was without internet standard correction. But within the central mix, we also added deuterated compounds, which aim to be used as internet standard for this central mix. So when you do the correction with the internet standard areas, this is the QC chart you obtain. So you can see that the standard deviation average decreases a lot. So it's very interesting also. Now comparing the century mix QC chart with our QC39 QC chart. So actually we injected each time since July. Each time we injected our QC, we also injected the century mix on the same day and so on to have this overlap and to compare both. So this is the QC for the century mix, and this is the QC chart, sorry, we obtained with our QC39. So what's interesting here, so even though you have like a difference in standard deviation, you can see that we have the same shape with this QC chart with the slight decrease, and again, it was before the column change. So, and what is interesting also is those three last points, that was the 2 weeks before we decided to change column. So if we just look at the QC chart on the bottom with the QC39, so those 3 pins seems okay. They are going to be close to the limits of one standard deviation at some point, but it's okay. But with the century mix, it's already on the limit there. So monitoring more compounds can be also interesting because you have more information, of course, and so you can go to conclusion quicker. So that was for our global, I will say, instrument follow-up on a week basis, depending on injection and project. But what do we do during specific method studies? Sorry. So this is an example of a work our PhD student Julia Bensada did during her master thesis year. So she was working on SPME GC GC-TOFMS, and she wanted to identify some volatile organic compounds produced by a specific bacteria. And here you have the chromatogram she obtained of the media incubated by the bacteria. So what did she do to follow the instrument during her study? She actually built a very specific QC chart within a day by using the QC39. And for that, she used the exact same method that she will use for all the injection samples. So SPME method, chromatographic separation method, mass method, and so on. After she injected all the sample, randomized of course, and each 5 samples she added to her sequence a new injection of the QC39. At the end of the day, it's what she obtained for 2 of the compounds she monitored during their study. So on the left, you have the QC chart she built before the injection, and then for each compound, she monitored the areas to see if it was still acceptable according to her method. So this is something also you can add to your QA/QC system in your analysis when you are performing very specific analysis like that, SPME, bacteria, and so on. So that leads me to the take-home messages for this presentation. So I really hope that I convinced you that following more compounds helps monitoring instruments, and I hope that I convinced you that the centromics can be used as such. Also, if you really want to be sure about your injection and your analysis, it's very good to build an instrument follow-up QC chart, what we did for instrument, but also to include QCs during your study follow-up to be sure and to have like insight about what's going on. And that can be maybe used as a base for your own implementation of QACC system for your metabolomics analysis. As a perspective, we will of course continue the follow-up of this instrument I just presented today, but we will also implement this system on all the instruments in the lab using both our in-house QC39 and the centromics to see the differences between the two of them. The idea is also maybe to create very specific QC mixtures that aim to be used as QC, derivative for the centromics, but with just some compounds that can be very related to one specific field or another. And we will work with that also on multivariate chart control by using PCA to evaluate reproducibility during our specific studies. So this is now my favorite slide, the easiest one. So with that, I would like to thank very warmly all the members of the group I've been working as part of for 2 years now. It's been a pleasure to work with all guys for 2 years now, so I'm very glad. Also, all the, of course, the collaborators and sponsors for this project. And if you want to see a bit more of what's going on in our lab, I invite you to follow Roberto, which is actually our coffee machine. He has an Instagram account and he knows everything because he's a real gossip. So with that, I will also like to thank you all for your attention.